CompTIA Cloud Plus, Observability Operations in the Cloud. First off, let's define observability according to CompTIA. Observability is all about maintaining visibility into cloud environments to ensure performance, reliability, and security. These concepts are often tested in scenario-based questions on the Cloud Plus exam. So it's really going to help to think in terms of real-world troubleshooting and monitoring workflows. So my approach in this lesson is going to be more about how to approach the exam. There's kind of an old saying that says you can't teach somebody how to do brain surgery over the phone. So there may be some degree of you taking responsibility and getting your hands on some of these tools and becoming familiar with them. First off, we have advanced logging. We need to understand there's different log types. For example, in a Microsoft environment, you have the system log, you have the application log, there's a security log. Different types of applications have logs. For example, email servers, domain controllers, web servers. There's also access logs and auditing logs. In the cloud, these types of logs are often stored in object storage, like Amazon S3, Google Cloud Storage, and Azure Blob. You should know how to configure log collectors, at least to a very basic degree. We're going to look at syslog and SNMP here in a moment. Be familiar with log retention, different access controls. Remember, we want to have least privilege principle, we want to have separation of duties, and also the importance of automation for log analysis. And often, we're going to use a SIM and source system to do that. For example, something like Azure Sentinel. And logging should support compliance, forensics or e-discovery, and performance monitoring. There's many versions of syslog, just like there's many different operating systems, like there's syslog-D, audit-D, there's syslog on different Microsoft systems. But they all have 8 levels. The lowest level is the most severe level, level 0. That one's kind of rare to see because often the system's not even functioning at all. So you might get that one if your syslog monitoring tool, your management station, just simply can't reach it. And then the one that's often filtered out because it's kind of noise is level 7, which is debug. So what we do is we kind of trap at different levels. If you're going to collect at notification, level 5, then you're going to collect everything from 5 down to 0. And you can send a trap, which is like a UDP packet, or you can do an inform, which is kind of like a TCP. And also, look at these descriptions and remember those on the exam. SNMP has been used for decades. It's often used for change in configuration management, network operations, enterprise resourcing, and it's a client server where you have an agent running on some type of device and you have management stations and they leverage a management information base called an MIB. So if you were going to identify, let's say, some type of Cisco configuration or configurable item, something you could change on a Cisco switch, it would be identified by starting at the root, being 1, and then going to the next level with a .3. So 1.3.6.1.4 .1.9, then whatever the configurable item is, and there's a gazillion of them. And so that's how you can either read information, metrics, or SNMP has write capabilities and change capabilities, so you can use your software to actually change the configuration on the Cisco switch. Today we use SNMP version 3 because it has security built in and it doesn't use the old community strings, which were security vulnerabilities. You should be familiar with syslog and SNMP. The next aspect of observability is aggregation. Logs and metrics from multiple sources should be centralized using tools like ELK Stack, CloudWatch Logs at Amazon Web Services, or a third-party security information event management system, such as Splunk, powered by Cisco, or a cloud-based solution, the aforementioned Azure Sentinel. And there's also others, from SolarWinds and other companies. Aggregation enables correlation across services, making it easier to detect patterns and anomalies. Remember, when an event or an incident happens, it's probably going to trigger multiple logs and alarms and alerts from multiple systems. So you have to collect them, correlate them, aggregate them, and deduplicate them. Next, we have tracing. Tracing follows a request's path through distributed systems. Candidates for the Cloud Plus exam should be familiar with distributed tracing tools used in the cloud. For example, AWS X-Ray or OpenTelemetry. These are used to identify bottlenecks or failures, especially in microservices. Tracing is useful for performance tuning and RCA, root cause analysis, also known as cyber forensics or an aspect of e-discovery. It's also important to understand key performance indicators or KPIs. For example, if you're running a virtual instance of Red Hat Enterprise, understanding CPU usage or utilization, memory usage, disk input-output or I/O, or IOPS to an elastic block drive, and network throughput. Metrics should be baselined and then monitored for deviations. And one should be familiar with thresholds, tagging, and resource utilization tracking. For example, in CloudWatch at Amazon Web Services, to use the launch template for your auto-scaling instances and ongoing optimization and management. Our final component of observability on the Cloud Plus exam is alerting, which can be triggered by metric thresholds or log events from various virtual systems. They can use email, SMS, and dashboard channels called alert channels. We might also leverage other things like a simple notification service with a push or pull or publish and subscribe relationship. And then alerting strategies include things like maintenance modes, escalation policies, and reducing false positives. Let me talk about those real quick before we finish up here. Maintenance modes temporarily suppress alerts during planned maintenance to prevent noise from expected changes, like server restarts, doing patching. So this avoids alert fatigue and it reduces false alarms. And then escalation policies define who gets notified and when, especially if the primary responder doesn't acknowledge the alert. This ensures that critical issues don't go unattended, and it adds redundancy to response workflows. And then finally, false positive reduction basically is the refining of the alert logic to minimize unnecessarily or misleading alerts. So techniques would include threshold tuning, log filtering, introducing anomaly detection, maybe an engine or even an AI machine learning type thing, and then traditionally using context-aware rules to focus on actionable incidents. I hope this lesson was informative for you. I want to thank you for viewing.